Oh, looks like a job for Dr. Kevin. Looks like you need some gamma rays.
I already feel better.
Okay, so a couple uses for gamma rays are that they're used to kill cancer, and they do this by being focused on tumors, and which shrinks them, and it also kills the cells that cancer produces. It's also used in the military, which it causes nuclear explosions, so they are able to be used in nuclear warfare, and also a product of nuclear warfare causes more gamma rays.
In this equation, the symbol lambda is wavelength, which equals velocity over frequency. If the wavelength of a gamma ray is 10 to the negative 11th and the velocity is at 300 million, the frequency should equal 300 million divided by 10 to the negative 11th, which is measured in hertz. In this equation, E is the energy in a photon measured in joules. In E equals hf, h stands for Planck's constant, which is at 6.626 times 10 to the negative 34. Using frequency in the last problem, E equals 6.626 times 10 to the negative 34, which should equal 3 times 10 to the 19th. In joules.
Alright, we're going.
Oh, I didn't see you there. I guess you want to learn about gamma rays, huh? Well, my famous work with the gold foil, known as the Geiger-Martin experiments, were really crucial, and they were a watershed series of experiments which discovered that every atom contains a nucleus where its positive charge and most of its mass are concentrated, thus deducing this by measuring how an alpha particle beam is scattered when it strikes a thin metal foil. This ultimately led to the discovery of gamma rays that could penetrate several centimeters of lead. Also, gamma rays were not affected by the magnetic field, therefore them having not an electric charge.
Hi, I'm Paul Villard. I found gamma rays in 1900 while I was experimenting in France with radium. I realized that these were not X-rays because they had deeper penetration and they were shorter frequency. And I can assure you that gamma rays are effective in fighting cancer cells.